Hi, everyone. Thank you for coming. Today, we're going to be talking about FugueSQL, the enhanced SQL interface. Han and I actually met virtually in the Databricks Summit 2 years ago, where he presented about Fugue, and then I got involved. So just about us, this is actually the third Fugue talk in this conference and the last one. Yesterday, there was a presentation on distributed machine learning in Lyft, and just a while ago, there was a talk about hyperparameter tuning, and this is the third talk where we'll be going more in depth in the Fugue library. So about us, Han is the tech lead of the Lyft machine learning platform, and I am an engineer at Prefect, which is an open source workflow orchestration company. So a bit more about the Fugue project. If you're not, some of you may already be familiar with Koalas or Modin. What Koalas does is it lets you is a Pandas interface that runs on top of Spark. Modin is a similar thing where it's a Pandas interface that runs on top of Ray or Dask. So these two semantic layers are tied to the Pandas interface, and they take your Pandas code and they run it distributedly. In PyCon 1 month ago, we had a talk where we discussed the limitations of the Pandas semantics and why it struggles to be the grammar for distributed compute. So today we'll be talking about the limitations of the SQL side of things, and we'll be talking about why SQL also struggles to be a grammar for distributed compute. So with that said, Fugue sits in the middle where we don't choose between Python or Pandas, or we don't choose between SQL, or we don't choose SQL. We allow users to to choose their preferred grammar and express their workflows in that grammar. And then we take care of porting it over to the distributed setting. So we support Python, Pandas, and SQL, and we currently support Spark and Dask. And then we also have plans to support Ray in the future. Another interesting thing is we also support DuckDB. If you're not familiar with DuckDB, DuckDB is a OLAP database on top of flat files. So what we can, it's like the SQLite version, but for analytics workflows. So something that a lot of Fugue users do is they can prototype their workloads on DuckDB on small data, and then when they're ready, they can change the backend and bring it to Spark. So something important on the right side of this picture is also the interoperability of those backends. Fugue supports interoperability of Python, Pandas, and SQL. Something we allow also is that SQL can be the predominant interface and invoke Python code as well, compared to Spark SQL currently, which is normally sandwiched between Python commands. And with that, I'll start with the limitations of the SQL semantics. So we have a data frame here for tests, and we just have 3 columns. The first one is some kind of group. The second column is some kind of order, or some kind of, just some kind of, like, you can think of like a timestamp or something. And the third is the value that we're concerned about. Now, if we look at this query, it may be a bit hard to read at first, and that's one of the points we want to discuss, in that SQL has a lot of boilerplate code that makes things hard to read and maintain. So the first thing here is that there are around 4 sections here. The first one is where we calculate the rolling mean and the rolling standard deviation. That's the first chunk of code. And then the second one is where we use that rolling mean and rolling standard deviation to calculate the rolling z-score. After we calculate the rolling z-score, we have this table called top, where we want to get the top groups with outliers. So we look for the ones where the z-score is above 3. And then the last part is where we do an inner join to collect those records. And with that, let's talk about the first issue of SQL, in that we are normally limited by one select statement. So if you think of operations where you want to maybe return 2 data frames, standard SQL already limits that. It's also very hard to maintain this, because what happens is you have to put all your logic in one gigantic query, and it becomes hard to iterate. So the first issue here is that we have a lot of boilerplate code just to create all of these temp tables. SQL especially but allows people to write queries inside going outside, as opposed to be read top down. So this is already one of the friendlier ways to read SQL, and it still has a lot of boilerplate code. The second thing is we have a lot of temporary tables in between in between our first and last steps. All of these have to be named entities within our SQL query, even though we don't really need them at the end of the query. This from statement selects data from a Parquet file. Even though it's seemingly trivial, this actually introduces vendor lock-in because it's a Spark SQL specific syntax. So what happens is this code cannot run on, let's say, some SQL interface to Pandas, or for example, on DuckDB. And what happens is this code only becomes applicable in the Spark setting. So this is one of the simpler cases of Spark-specific syntax, but there's also a lot of other Spark-specific syntax that is introduced as well that doesn't translate well to other engines. And the last thing is, most importantly, that this query can be ineffective. Because if you have a diamond-shaped workflow where you have a table and then you have two queries that are created from that original table, and then you join them, there's a chance that in this case that original table is computed twice, one for each fork of that diamond shape, and then when each time it branches out, it will calculate those unless we explicitly persist, if you're familiar with Spark. But the problem with the SQL interface is that we don't have the grammar to describe these distributed computing operations. So we don't have keywords such as persist, such as broadcast, or even stuff like group map are missing in the standard SQL interface. And the last thing I want to mention is that SQL, of course, if you have to iterate over this, it's very expensive and very hard to debug. Because what happens is if you want to fix something in this query, you normally have to keep rerunning the previous computations as well, especially if it's not held in some kind of cache. So what happens is as you're iterating, you keep rerunning things again and again, just because SQL by nature is hard to iterate with compared to Python and Pandas code. And with that, I'll hand over this talk to Han, who will demo FugueSQL and how we address these issues. Thank you.
Hello, everyone. So now I'm going to give some quick demo about FugueSQL. So actually what you can do, I mean, you can kind of reproduce these things from Fugue tutorials. And if you click binder, it will start that environment I'm using. But today I'm just going to use Docker instead of the binder because I'm not sure if binder is, because it's a free service, so I'm not sure if it is stable enough. And also the machine behind binder is weak. So I'm using just the Docker to give the demo. But you can definitely try everything I talk about on binder. So let's start. So first of all, let's have some code that is generating the mock data that we talked about in the previous slides. So as you can see here, we will use 200 time series. Each time series will have 10,000 data points. And we will use the window size 200 to compute the rolling z-score. Okay, so I will generate this mock data and save it to a local file. And then I will just start a Spark session in the most standard way. And now we're ready to look into this SQL and see how we can improve this using the FugueSQL. Okay, so of course, every time when I run a SQL or run something, I will just run the catalog clear cache so that every execution will start from a clean state. So the time we see here, the execution time will be like more consistent and fair to compare with each other. In your real job, you shouldn't use this because every time you just erase all your persisted data frame, that is what you don't want to see. But here it's just for demo purposes. Okay, so now let's look at the SQL. first question, how can we iterate a SQL on Jupyter Lab or Jupyter Notebook? So in Fugue, we can do this. Just give magic, then you see the syntax are all highlighted. Okay, so this is the first step. So SQL, FugueSQL is an extension of standard SQL. So whatever standard SQL can do, we can do. So this already can run, but we can do something that's better for iteration, better for development. What we want to do is we can have a print additional syntax in order to print out some rows of the traditional SQL so that we can see what's going on there. Another thing is we can specify what kind of backend we want to run the SQL on. For example, if I don't specify anything, I will translate this SQL to Pandas operations to run. I don't want to demo that today. What I want to demo is just directly to use Spark as the backend. So this SQL will be translated to Spark SQL to run. Okay, now let's run it. Okay, this will take a while. So while we're waiting, let's just continue on the next cell. Let's see how we can improve this. So first of all, in Fugue, we do not have to use CTE statement with statement. We can remove them. It's a little bit too tedious. So what we can do is we can use the Python-like assignment for your each steps. So let's firstly remove the CTE statement. Okay, so this is the first step. It doesn't affect the speed. I mean, I'm not doing any performance improvement. I'm just trying to simplify the syntax. Okay, next step, we want to remove the vendor lock-in. So look at this paquet. What if I change this to DuckDB? It will not run because DuckDB doesn't understand this. So what I can do is I just use additional syntax. As you can see, the time is almost the same, 21 seconds. So I can use, like, for example, load tmp.t.paquet. And then I can give a name to it, right? I can give a name just like other steps. And you can say, I just want to get it from SRC. Then, so this code will be vendor lock-in. Whatever backend you use, Spark, DuckDB, Dask, or even just Pandas, it will just work. But what we can do is we can do better. We can make it simpler. So look at this SRC. It's only used by the next step. And the next step is only consuming the immediate last step. So what we can do, we can make steps anonymous. We can just remove the from statement. And this is the same. We do not need this. It's not necessary. So I would just remove it. I mean, you can keep it, but it's not necessary. But I have to keep the Z on top. Why? Because in the next step, in the join needs two table names. So they must have names. So I have to keep the names. And I remove the unnecessary names. And for the worst, it's the same. It's not necessary because it's only used by the last step. Okay, so far, you see, this SQL versus this SQL is already a lot simpler. What? I need, like this? Okay. Sorry about that. Yeah. So you see, this SQL and this SQL, it's already a big difference. Okay, so now let's talk about performance optimization. So far, I haven't done any performance optimization. Just this SQL, it will just run within the same time range. But how can we improve the performance of this SQL? So persist, right? Kevin talked about persist. How can we persist? So the only thing you need to do is adding another syntax called persist. So we explicitly persist Z here, so that if the lazy evaluation happens, I mean, if min std and the Z score compute they are like evaluated twice, it should take a lot of time, right? So it may happen, it may not happen. It really depends on how Spark or some other execution engine is optimizing your workflow. But again, it's not in your control. But here, if you give a persist, the control is on your hand. You know what you are doing. You're explicit about how you want to optimize this SQL, right? So let's just give a try and see if this persist will help or not. As you can see, with just a persist statement, 12 seconds, and original SQL, 21 seconds. So what does that mean? That means, okay, if you want to optimize this with statement, what do you have to do? You have to break this with statement to 2 with statements at the Z step, and then you have to run the first step, push the data frame back to Spark, persist it, and then register back and run the second statement. So your logic, your computing logic is broken up, and it will be very hard to maintain and difficult to understand, right? But in Fugue, you just need an additional syntax so that you can keep everything still in SQL. Okay, so this is not the end. Let's think out of the box. Look at this statement. If you are doing SQL, if you want to compute the rolling z-score, this is the only way. There is no shortcut, right? But what if you want to do that in Python? Think about that. Using pandas to express the rolling z-score, it could be a lot easier. So let's just take a look at the Python code. Let's copy paste here. So look at this pandas code. This is just pandas code, nothing else, no Spark. It is a function that's just to deal with one-time series, right? And the n is the window size. We just get the value rolling, and then we just compute the value minus mean, absolute value over the standard deviation. Then we compute the z-score, the rolling z-score of this time series. Right? So it's not only expressive, but more importantly, this is fully unit testable. This is just a plain piece of Python code, and you should unit test it if you want to put this in production. Think about that. How do you unit test this? It's not easy, right? But in Python, you can test it. So now the question is, how can we apply this Python function inside the SQL to further simplify the SQL block? So let's just do it. So what you need to do is, again, remove more code. Let's just remove more code. And what we need to do is transform pre-partition by name and pre-sort IDX using z-score, n equal to wing size. So as you can see, this is how we invoke the plain Python function inside Fugue. It is additional syntax, but look at this code, how simple it is. It's much shorter and also more expressive than what you use in this traditional SQL approach, right? But common sense told us that using Python in Spark is normally slower than just putting everything in SQL, because SQL, they just keep running in JVM, right? And they do not have to, to do data transfer between 2 languages. And actually, you can see the time. That proves our theory, right? So it's 15 seconds. Although the code is much simpler, it takes 15 seconds. And this takes 12 seconds. But actually, we have one more optimization that we can do. So we will just let Fugue to use Pandas UDF. Just with this switch, we turn on the switch, let Fugue use Pandas UDF, and we will see how long it takes. Now, only 7 seconds. What does that mean? That means after all these iterations, we figure out the simplest solution. That is also the most testable solution. That is also the fastest solution. Thank you. So I'm not saying this approach will always be the better one compared to other options. But the point here is developers, engineers, scientists, they need to have the flexibility to test different approaches and to find the best one for their specific solution. And FugueSQL is designed to simplify this, to minimize any type of boilerplate code so that you can quickly experiment, switch between different options, and find the best one for yourself. OK, the next demo. Let's switch to the next demo. Now we want to talk about Databricks. Right? As you can see, I'm still on this Docker image, but we will use Databricks. How to use Databricks on your local machine? Probably you already tried using a Databricks Connect, right, and register. But using Fugue, you can make this totally programmatical. You don't have to go through that Databricks Connect configuration. I don't remember that command, but what you can do is you can just provide a dictionary of host, token, and cluster ID. And of course, it's not best practice here. What you should do is you should get those values from some secret store, or you can save them into the environment variables. Both are fine. Here is just for demo purpose, I will just keep it simple. Right, so as long as you have these three values, and let's do some quick ETA using the Databricks cluster. So in Fugue, the cluster doesn't have to exist, or the cluster doesn't have to start, because Fugue is able to start the cluster automatically. So, but here, because I need to demo quickly, the cluster is already started. So let's just use the cluster to do some quick ETA. Again, I'm using FugueSQL. This time, I don't want to use Spark. I want to use Databricks as our backend. And in order to use Databricks, I will just provide this configuration. OK, now let's just load this file and print. So this whole thing, this cell, is actually running on the remote the Databricks cluster. And you see already get some result back. With this, at this point, we will think, OK, can we just pull some sample data down into your local box and iterate? Let's do that. Sample 1%, seed 0, and yield local data frame as test. If you do this, the execution will happen on Databricks, but the sample data is put onto your own machine. And at this point, you already can turn off that cluster. You can stop that cluster now. It's no longer in use, because the next steps will just be local. And you don't have to waste your money on idling clusters. And actually, here in the configuration, you can directly provide a cluster, the JSON of the Databricks configuration, and we will create a cluster for you run these statements, and then stop that cluster for you. So to be short, FugueSQL can use Databricks as ephemeral clusters. So you don't have to waste money on any idling clusters. Okay, so now at this step, I already have test as a local data frame. Let's take a look. You can see that this data frame is very similar to the previous data frame. And actually, we also want to perform the previous operations. Let's see how to iterate. And in order to iterate, of course, you can start another kernel with Spark and just iterate locally. But we can do better here. We don't have to switch between different notebooks. We just keep everything just here. We don't use Spark to iterate. Now we use DuckDB to iterate. FSQL, let's just write the simplest DuckDB. Select star from test, because here I yielded the test. So test is available both in normal cells or the FSQL cells, and print. As you can see, how fast. Right, okay, so now I can start my iteration. Right, so remember we have this statement. Let's just copy paste. Let's just copy paste and see if it works. So every step, you see how long the iteration is 144 milliseconds. You're iterating on smaller data. And you already see, okay, this output is what I expected, right? Okay, now let's move to the next step. Let's write the next step. So here you can persist or not persist, it's totally fine. So as you can see, now I have finished the 2 steps. It works fine. Okay, so now let's run another step, pop. And now you see the top is here. So now assume that computing Z and computing top are very, very expensive. Every time when you add one more step, the cell will spend more time to compute, right? So how can we iterate this process? You need to break the lineage. What you need to do is you need to have breakpoints so that you can continue from there, right? So what we can do in Fugue is you can yield DataFrame. And here I will just yield DataFrame. So now you understand why we want to use yield, because in Fugue, we can yield multiple data frames from the single SQL statements. And then they will be available in the cell. They will be available to use in the next SQL statement. So how can we, so after we yield a statement, actually we create the breakpoints. Those previous statements will not need to be rerun. Now let's just work on the following steps, the final several steps. Okay, so the next several steps is just, you can just copy paste. And they will just give you the result because these 2 tables were yielded into the cell. So we can just make them run here. So as you can see, it's like FugueSQL is like a Lego. You put them together or you separate them. It's so free, right? There is no rewrite needed to do these kind of things. Okay, after our iteration, we want to put everything together. Let's just put everything together now. And after I put everything together, the yield will no longer be necessary. I mean, you can keep them there, but I can also remove them. So just make this additive. Okay, I will just keep this part. And I will also have this part. Like, for example, now I don't want to run this in DuckDB. I want to run this on Databricks. How can we do that? So we just copy paste these 2 lines of code to here. Now I'm running the workflow end-to-end on Databricks instead of DuckDB because I have finished my iteration. This logic is good enough to be productionized. Maybe in the end, I can say save, overwrite, like a src dot out dot parquet. So this is more like a production pipeline where you read from a file and you save to a file. And this whole thing now is running on Databricks. So how can we productionize this? Simple. You just say, I want this to be a SQL statement, right? And the next step, you just say from FugueSQL import FSQL and FSQL SQL, and you can provide src. And then here is the important thing. You can unit test it with just a run. You can provide a local path and just a run without any backend or just with DuckDB. So this is how you unit test the FugueSQL end-to-end. And when this is ready, you can just change this to Databricks and with the configuration. Then everything, and also change the source to a real data source, then everything will just run on Databricks as a production pipeline. So this is how FugueSQL can help you simplify the SQL as well as help you to accelerate your iteration on your data pipelines. Thank you. And here are our resources. If you are interested, you can take a look, and we are happy to collaborate. If you are interested, just let us know. Let's chat. Thank you.
Awesome. Thank you, Han. Thank you, Kevin. That was fantastic. We have a couple minutes for questions. So.
I was wondering if I could mix some results of Fugue with great expectations, for example. But I think I already know their answer, because when you use Wield, you receive a data frame, something like that. Then I can use this data frame with other frameworks, something like that.
Sorry, can you repeat your question?
How can I mix different frameworks like Great Expectations, for example, inside the pipeline or something like that?
Well, so there are two ways. So one is in Fugue, you can invoke Great Expectations to do distributed data validation. Actually, last year in PyData, we gave a talk about how Fugue and Great Expectation can integrate together. Another way is Great Expectation can use FugueSQL as a backend, so that it can immediately, access to multiple data sources. But that approach we haven't had time to, we haven't had time to work on. Yeah. Thank you.
Question?
Hi, thanks for the presentation. You showed off persist in that first demo. Is that just looking for any changes within that code block if it needs to rerun? Or
no, so persist, this is a very important concept. Persist, there are several different types of caching. Persist is stateless caching. That means just during your iteration, that persist will work. So if you wanted to work like a cross execution, we have something called a checkpoint or deterministic checkpoint. If you put that explicitly, then you run the second time, the previous workflows will not run. It will just use the deterministic result. Yeah.
Good question. Thank you. Folks, we're on time. Thank you again, Han and Kevin, for the presentation. One more round of applause. Thank you.
Thank you.